It took me like, what, 2 months, it appears? I'm slow. But I need to have communication with you, and this is very important to me. Okay, chapter 2, we are going to look at applications of differentiation. In other words, why did we study chapter 1? What is it for? And we have many applications here. Max, min. Finding the max or the min of a function. Maybe profit for the maximum, maybe cost, minimum for cost. We can be asked to determine max, other than max min for profit, as I said, a cost, or just a simple function. We may be asked to graph a function. We may be asked to find increasing or decreasing intervals for a function. We may look back at the demand and supply, and so on and so forth. Many, many, many applications. Okay, but we have to start slowly, because I have a lot to tell you, how to get to an increasing, decreasing interval for a function. When is a function, increasing and giving us profit, for example, where the function has a maximum or a minimum. And then the first application will be graphing of a function. Also, another application will be approximations. Many applications we are going to look at here. In order to ease into the topic, I'm going to select a simple function and discuss increasing, decreasing, and critical numbers first. So you can say, what is a critical number and what are you talking about? True. I'm going to choose a function. Let's say problem 10 on page 201. So first I would like to illustrate two very important concepts. One is called critical number, of course, or numbers. A function can have critical numbers or just critical number or none at all. Doesn't have to have critical numbers. And then increasing, decreasing intervals. And I think I'm going to throw in the third one and not wait till later, max min, because they are all so related. These three concepts go together at all times. Okay, I want to say first, if a function does not have a critical number, it cannot have a max or min. So that's our first note. No critical number, Cn, comma, no max min. Here's another note. If a function has critical numbers or just one, it does not mean that it has max min. Something else has to happen. But if it doesn't have a critical number, it's guaranteed not to have a max min. So like with the limits, I said 0 over 0 is not guaranteed to exist, but it has potential. 0 over 0 is not guaranteed that it has a limit, that the limit exists, but it has hope. So it may happen. But if it's 5 over 0, it's never going to happen. That's dead. It will never have a limit. So here I'm saying if there is no critical number, guaranteed no max min for a function. But if a function has a critical number or critical numbers, it does not mean that it has a max-min. Something else has to happen. There is no guarantee. Okay, so first let's talk about what is a critical number. Critical number can be of two kinds. Critical number can come from f prime of x being 0. So for a function, I determine the derivative, I set it equal to 0, and I get that x equals 3, and let's say x equals -1. For example, these, from solving the equation, I obtain these. For example, these two are critical numbers. Will these become points of max-min? Not necessarily. I have other things to do before I decide whether they become max or min, or none of the above. Critical numbers can also come from a different source, from f prime of x being undefined at, oops, I didn't mean that, at points where f of x is defined. You could say, well, that's difficult. What do you mean by that? Okay, here's what I mean. A function, the derivative of a function could be undefined. In how many situations? Several. If you remember, this is the graph of the absolute value of x. And we set it at a corner. This is a corner. The derivative is undefined. And this will be at x equals 0. So the derivative is undefined because there are two tangents here. One with a negative slope and one with a positive slope. So at this point, where the function has a corner, it's not differentiable. It's continuous, but not differentiable. So at this point, the derivative is undefined at 0, but the function exists at 0. So for this situation, x equals 0 is a critical number because the derivative is undefined, but the function exists at that point. So that's an example of this situation. A function can have critical numbers coming from both sources. Doesn't have to have this. It can have only this. Doesn't have to have this. It can have only that. It can have both, or it can have none. None. So why do I need to investigate critical numbers? I always investigate critical numbers to find out whether the function has a max or a min. If there are no critical numbers, then the function doesn't have a max or min. And in the process, we will figure out what's happening with increasing, decreasing intervals. Okay, now I didn't copy the function. I'm going to copy it here. Stop me if you have questions, please, anything. I said 10. Was it 10? Yes. F of x equals x to the third minus 3x plus 6. Find any relative extrema. That's what it says. And along the blah, blah, blah. I don't care for the text right now. So what we're going to do is, so when we talk about relative, so we know extrema. This is the plural of extremum. So find relative extrema or relative extremum. That's a singular. We're really asked to find where the function has a turn. So relative extrema, max or min. That's what we are asked to determine. Determine where this function has max or min, or we also call them turns. You notice that in this situation, the function is increasing. It reaches a maximum. It's called relative. In some books, you're going to find the word local. Same thing, relative or local max. So it's increasing, it reaches a maximum, then it's decreasing, it reaches a minimum, and then it's increasing. Notice that at these points where the function has a max or a min, what is the slope of the tangent?
0.
Yes. So for max, min, slope of the tangent is 0. In this situation, the slope of the tangent could be undefined. How come? Because critical numbers can exist when f prime is undefined. In this situation, the slope is 0. F prime is 0. But in this situation is when the slope is undefined. Okay, so first we are going to find at step number 1, find critical numbers for the function f of x equals x to the third minus 3x plus 6. In order to find critical numbers, what do I need to find first?
Wild guess, the derivative.
Thank you. So f prime, that was a good one. A good guess. Okay, so f prime equals, who would like to give us, okay, maybe Noor will like to tell us now what is the derivative of this. Noor, are you with us?
Yeah, I'm here.
Okay, good. Can you give us a derivative?
No, I'm not sure.
Who would like to give us a derivative?
I can get the derivative.
Okay, Gabby, go ahead.
It's 3x squared minus 3.
Very good. Okay, now, I asked myself, and I have to. Let's start with the second option. Can f prime be undefined?
No.
No, it's a polynomial function. It's quadratic, never undefined. So f prime equals undefined, none, no critical number. Okay, so can f prime, however, be 0? I tested this, none, no x values. Now I have to test this. What do I get? 3x squared minus 3 equals 0. How do I continue? What is my first step here after writing the equation?
When you move the 3 to the other side, so add 3.
You could. But you know me, I want to clean it up. As a friend of mine used to say, she says, I always run a clean ship. So please, let's run a clean ship. You can either factor or take one to the other side, but if you forget that this is basically the absolute value and you do not write plus or minus 1, then we are in trouble. So far, so good. Are you with me, everyone? Is that a yes? Is it a maybe? Anything?
When it says there's the equals 0, what does it mean that we set it to 0 and then
I replaced f prime by 3x squared minus 3, and I set it equal to 0.
Okay.
Everyone else okay? So now I'm going to kindly ask you to get used to the following table. It's an extremely important table. X, f prime is the next row, f of x is the next row, and we will add another row to this table. Again, what is the domain of this function?
negative infinity too.
Right, it's a polynomial function, a nice polynomial function, no problem there. And we already have a -1. 0 has to be in the table at all times, even if the function is undefined at 0, which is not the case here. And tell me the values of the derivative at -1 and 1.
Zero for both.
Thank you. Of course, that's how we got them. Okay, very good. Now, in the derivative, which is right here, I want you to plug 0 in here and tell me the sign. I don't care about the exact number. I just want the sign of the derivative between -1 and 1, and I pick 0 to plug in.
It would be negative.
Thank you. Please pick, let's say, -10 and +10. I don't even want to put them in the table. I don't want them there. Plug it in and tell me the sign here and the sign here.
They're both positive.
Of course. Now we need to determine this value by replacing, how do I get these values? Michelle, how do I get these values?
By plugging in those numbers.
Right.
into the original.
Right. So let's plug it in. So this is -1, but this is +3. 6 plus 3 is 9 minus 1. -8. 1 plus 6 is 7 minus 3 is 4. I also would like here and here to tell me by looking at anyone, not necessarily Michelle. So I want you to tell me again, like we just did a few minutes ago, which of these 3 terms is the most powerful one? Right. So please, as if you're plugging in negative infinity in x cubed, tell me what is the symbol here and what is the answer. What will be the limit here? Thank you very much. And here? That's it. Perfect. So now, at this point, we will discuss and make sure that these 2 rows work well together. If they do not work well together, I'll have to go back to the drawing board. I'll say, oops, I have an error. Before we do that, let me emphasize again. This is an example. If, as you know, at any point where the function is differentiable, it has a rate of change, which is the derivative, which is the slope of this line, which is the slope of this line, which is the slope of this line. So when the derivative is positive, right, we know that lines like these have a positive slope. Lines like these have a negative slope. So every time the derivative is positive, the function must be what? What is the function doing when its derivative is positive?
Increase?
Yes. So f prime positive, f is increasing. F prime positive, f is increasing. So on the other side, when f prime is negative, maybe I should write an arrow so it's clear what I mean here. So when the derivative is decreasing, when the derivative is negative, what does the function do?
It's going down.
Very good. So please, these are key concepts so far. Critical numbers, and these are the intervals of increasing, decreasing. Okay, so coming back to my table, I have to test that these 2 rows work well together. Ready? So the derivative is positive. What should the function be doing if the derivative is positive? Yes, is it? Is the function going up from negative infinity to negative 8?
No.
Very good. Do you want to have in your bank account negative infinity or negative $8? We will always take negative 8 versus negative infinity, right? Okay, good. What is the function? What is the derivative doing here? It's negative. What should the function be doing?
Going down.
Is it from negative 8 to 4?
No.
No, no. So I have to go back and look at my numbers and see what I did.
Wouldn't that mean that there was a turning point somewhere?
We will talk about that in a minute. Yes.
I think you messed up the equation when you got negative 8. It should just be regular.
Very good. That's very possible. That's why that's how I catch. I wasn't trying to make an error just to make a point, but that's why I said if these two rows do not work well together, I'll say oops and go back to my drawing board. I wasn't trying to do that just to make a point. No, I realized that there is an error. Okay, so let's try again. So negative 1. So this is 6 plus 3. So that's positive 8. Yep. Very good. I found my error. So from negative infinity to 8 is correct. And from 8 to 4 is correct. It's decreasing. And that's what the derivative shows. Now I fixed my table. Good. See here the derivative is increasing. So is the function increasing from 4 to infinity?
Yes.
Good. Very good. So we fixed that.